In this video, we'll have a look at how we can use a lookup table to define the depth of our adjustable shelf to select from specific increments. To do that, we're going to go into our adjustable shelf subassembly. Now, the nice part about this library is that the adjustable shelf subassembly is used on all the different products, standard products that are in the library. So if we make this change once, it's going to affect all of our cabinets, whether that's base, upper, tall. All the straight cabinets we're able to modify. If we needed to do this on things like corner cabinets or transition cabinets, there might be another adjustable shelf subassembly that we would need to modify. So if we go to our show subassembly list, we can see there's a few different adjustable and fixed shelf subassemblies. So if you had some specific application, you might need to make some changes in those as well. But for this one, we're probably just going to do it in the adjustable and fixed shelves subassembly. And so if we go into that subassembly, we can see that there are a variety of lookup tables already here. So what we want to do is create a lookup table with the overall cabinet depth and the depth of the shelf that we're going to use. So what I'm going to do is have a look at how the shelf width is calculated right now. So if I go to my cut parts and have a look at my size, it's coming from the adjustable shelf width. And so if I go find that prompt within my subassembly here, I can find it from the alphabetical listing here, so adjustable shelf width. So here's my formula. It's going to take the depth of the subassembly overall minus the adjustable shelf setback, minus if it's a curved shelf. In this case, it would be an additional curved shelf setback, and we can go and jump to those prompts within this list here. And then if we're using a rear line bore, there's a rear shelf clip gap to space it away. Now in this case, that's the formula I'm going to use by default if the shelf depth is less than my smallest available shelf blank. And so I'm going to flip over to lookup tables, and what I did, I just pasted that formula into this size and put that with a depth of 0. So if the depth is less than my first available cabinet size, I'm going to use the standard formula. But here I've got 3 sizes that I've defined as the trigger points for different adjustable shelf widths. And so here I've got my M2U, so that's just converting this value into metric. Now, if I'm just using a metric library, that doesn't matter. I don't need to do that. I can just type in the 300. I just include those formulas so that we can use them between different units. If we have customers that need this sort of application with different units, then I'll use that type of formula. But here I'm just entering the overall depths and then the corresponding shelf size. Now in this case, I've got 2 here that are going to come out with a 450. I really don't need this last line. It would still come out with the same size even if that line wasn't there. But just for the sake of the exercise, I've included it there. Now what I need to do is define that shelf name. So I'm going to go here and use the name manager. If this button doesn't exist, you're probably on an older update of the software, and you can use the workbook designer to access the name manager. So here I'm going to say name manager, and I'm going to say new, and this will be lookup table, and I'm just using that naming because that's how all of our lookup tables are named. You can call it whatever you like, but this is lookup table shelf width is what I'm going to call that. So I'm just going to copy that to my clipboard so I can use it later. And now you'll notice that when I highlight on there, it's highlighted and called that area of cells lookup table shelf width. So same thing here, lookup table. You can see that each one of these is a defined name, defined lookup table. So now what I want to do is add the option to use that lookup table. So either I can use full depth adjustable shelves or I can use the lookup table. So I'm going to say insert prompts here, that's standard adjustable shelf widths, and that's going to be a checkbox. So I'm going to make it a 1, so it's turned on and it's a checkbox. And I'll put some help text in here. Select to use standard blank widths for adjustable shelves. Otherwise, the full depth minus the setback will be used. or that I define that name. So I'm going to say define name to make sure that it's actually called use. Now this of course could be linked back to a global variable, so if I wanted an option to turn this on and off within the jobs, I would probably create a new global variable and link the formula to that. In this case, I'm always going to use this option, and so I'm just going to leave this as hard-coded 1 for this exercise. Normally I'd probably add a global for it. So now what I want to do is change this adjustable shelf width formula so that it uses that new option that I've created. So I'm going to go in here and I'm going to put an if statement in here. So I can use logical and say if, and what I'm going to do is grab the formula from that cell. So I'll just paste that formula that was in the formula there, paste that in if it's true. So I'm going to use this name, and I'm going to say subassembly variables and use standard adjustable shelf widths. So if that equals 0, so if it's turned off, then it's going to use the regular formula. If it's turned on, we're going to use a function here for the lookup. And so this function list, we're going to say lookup and reference. We're going to use VLOOKUP, so vertical lookup, and the value is going to be the depth. And of course I could paste that in using my subassembly variables depth. The range I'm going to paste in. So I typed in lookup table shelf width. You can see here when I have it incomplete, it's showing a name error. When I finish it off, it's going to come through as a range so that I know that I've got the name of that subassembly correct. This is going to be column number 2 that we're going to return. So based on the depth in the first column, it's looking up that depth in the first column and returning the value in the second column. And this one here, you can see whether it's going to be an exact match or an approximate match, and so here we're going to say it's a 1 so that it uses a closest match. So it's not going to be over the size, but that's going to be my formula. So I'm going to insert that one, and say apply formula. So now you can see my adjustable shelf width has calculated to 270. And the reason it's done that is the first size that can use my larger 450 shelf size is at 590, and because the depth of this product or this adjustable shelf opening is 573, which is less than the 590, then it's not able to use that one. So I may need to adjust these numbers a little bit to make them work the way I need. In fact, it might even make sense for me to have the same numbers in both of these columns, where I can, based on if the depth is there, then it'll do that. It'll use that matching size, because this depth of this adjustable shelf is the interior depth of the opening. So as long as there's enough opening there, then that will give me the size that I need. So a good way to handle that in this case would be to use my adjustable shelf setback prompt. So the depth has to be enough so that I have my adjustable shelf setback requirement in there. So now based on that, the size of the depth is the depth of my panel plus that adjustable shelf setback. So I have it set to 3 in this case. So the minimum size of opening that I can use a 270 shelf in would be a 273 opening. And so it's going to look down this list and find the matching value in column 2. So now I'm going to save and close this subassembly. When I do that, it's going to ask me how I want to save that subassembly. And because I've tested this, I am going to say save it to the project for now. Make sure it's good. I want to use it in all of my cabinets. If this was something I only wanted to do for one particular shelf, I could just say save to the current row. But I'm going to save it right now to the project. Now here you can see that when I did that, because I didn't change the front location, it is just using that shelf in the front area of the cabinet. So what I want to do is modify that so that the shelf always stays at the back of the cabinet. So here you can see my base point is at the back of the cabinet, or the back of the shelf. So that part looks fine, but my Y origin, so the location in Y, where that shelf is located, is based on the size of my shelf itself. So I'm going to modify that formula. So here, instead of this first section of formula where I'm taking the width of the shelf plus the shelf setback plus the curve setback, I'm just going to change that to depth. And I could use the base name for that as well. And so that's going to put it right to the back of the opening. So there you can see it's in the correct location now. And I've got my shelf where I need it to be. Now, I could go through and modify each one of those shelves through the part properties, but probably easier to use the edit design data here. Shelves are actually independently located, and based on a top notch or a bottom notch, they may have to change in depth based on that. So each one is a little bit different. So I'm just going to modify each one of those individually rather than dragging it down. And so the easiest way to do that is just using a find and replace. So I'll just find that first section of formula and say replace it with depth. So if I look down the list here, I've got my one updated formula that I modified in the part properties. But here I can see that each one of them is actually a little bit different because of the option for notching the cabinet top and bottom. It might have a different location at the back. And so the easiest way to modify that is just to grab this first chunk of the formula and use a find and replace. So I'm going to go here, paste that in, and replace it with depth. And if I do a find all, I'll see that it's just those locations. So I'm going to say replace all, and all of this will be updated. So now the nice part about this subassembly being shared across all my products is if I add in a different type of cabinet. So here I'm going to add a one door upper. We'll make it 400 deep and make sure it has some adjustable shelves, so that's all good. And there you can see that my adjustable shelves are using the lookup table that I created to determine the depth for that as well. So now I'm using 270 shelves for that particular one. So just by updating that one subassembly, we're able to affect all of those cabinets. Once I've tested and made sure that this is exactly what I want, and I want this to be the default for all of my shelves moving forward, in my case, I'm going to turn that off. I just want it as an option. So I'm going to say save it. And in this case, I'm going to save it to the project as well as the library. Here I've got this option for resolving prompt conflicts because it doesn't match what's in the library. So I'm going to keep what was in the template for the depth here. It's telling me that I've hard-coded the depth, which is correct, but I want these to come through here. So I'm going to say OK. And that's been resolved, so now I can save that. So now any new projects that I create from this point forward are going to have that option. Now, because I turned the option off, my shelf will turn back to the way it was previously. But in my subassembly prompts, I'll have the option to be able to turn on the standard shelf depth. And so here I have that option to do that, and if I want to save it for the project, I can say save it to the project, and all of my shelves from this point in this project will have that additional setback. So that's how you can use the lookup table inside of a subassembly to create some powerful modifications to your cabinets to be able to choose a certain size of part or shelf or something like that, and some of the ways that we can interact with the subassemblies to make the